Okay, section 30, which is graphing lines. Certainly this section's been covered through lecture. We talked about how to graph a line. We talked about plotting points on graph paper and noticing those points are collinear and then connecting the dots, so to speak, with a line. All right, not a line segment, but a line. And lines go on in both directions infinitely. We also talk about special points. And the special points will be, certainly, I'm not going to say they're always nice, but typically they're not bad. So special points are going to be an X-intercept and a Y-intercept. And again, that was discussed in lecture. For those students having trouble with that, you may want to watch the spot videos on the side if it's helpful. All right. So our point about this is it's really kind of a short lecture. We need to get to examples. Now, when I go to examples, I will kind of outline the procedure we'd like you to follow. However, there's a slight variance of this. Some students do other things, they just do other things. All right. The bottom line is lines should look like lines, and we should agree upon what these lines look like. All right. Now, when I say they look like lines, not all lines are the same line, but they all look like lines. They have something in common. Let me do another share with you. And we're going to go to the whiteboard now. Just give me a second to do so. And I got to do something over here. Got to share a screen with you, right? Okay, we're on problem number one from the examples. And when I'm coming over to graph a line, you need 2 points. And I'm going to encourage you when you take 2 points down here that you should look for the simplest points possible. So I'm going to make a little table up, and that table I'm going to put X and Y down. And I want to focus in on this over here. Now, a lot of students, what they do is they rewrite the problem. I don't think it's important, but you could. It's not going to change the problem. You could rewrite it if you want, but I'm not going to rewrite these unless I have to. All right. Sometimes I rewrite them to make them easier, but I don't think rewriting is going to be making this one easier. What I would do is pick a number for X or for Y that makes it easy. Now I'm going to say a really simple one would be 0. Now, if X is 0, what would you get? Well, Y would equal 7, 6 times 0. And what would that give me? 0 for the Y. Fairly simple. All right. Now, someone says, what's another number you could choose? Well, you could choose X to be 1 now, but I don't think that would be a good idea because I don't like the fraction. So I'm going to choose the X to be 6. Let's try that. What do you get? Y equals 7, 6 times 6. What happens over here? This cancels off. We're left off with, you left off with 7 for Y. I'm going to plot those 2 points. By the way, the provided graph paper may or may not help you. I'm not going to say it really helps me a great deal, but I certainly can count on it. And what do I need to do? I need to count to that point, which means I got to go over 6 and then up 7. I'm going to do that. And I'll try to do the best possible job of doing that. And I'm counting, by the way, 1, 2, 3, 5, 6. There somewhere, right? Let me see, 1, 2, 3, 4, 5, 6. All right, let me just point out what I just did now. So I counted over 1, 2, 3, 4, 5, 6. And I counted up 7. 1, 2, 3, 4, 5, 6, 7. I did a pretty good job. Now what I'm going to do, I got my 2 points down, equation of a line. What am I going to do now? I'm going to draw a line. Now what some students do is they do this. And they say, oh, that's the line. That is not a line. That's a line segment. This line goes on forever in both directions. By the way, we're not looking for perfection. We're looking for something that roughly looks like a line. That's my recommendation. My recommendation is to pick 2 points, draw a line through those 2 points. Lines go on forever, by the way. We got number 2. And again, my goal here is basically to pick a point. I put my table down. This is an equation of a line over here. And someone says, what's a nice easy point to choose? I'm going to say 0 looks easy for X. I'm going to plot that in there for you. What do you get? Y equals 3/5 times 0 minus 1. And what would that give you? Well, 3/5 of 0 is 0, and 0 minus 1 is minus 1. So we got a nice easy point. We'll plot that later, by the way. Now someone says, what's another easy value to pick? Well, I'm going to say X should be some multiple of 5 because it appears easy to do. Let me write this down. Y equals 3/5. Well, I pick 5, right? Again, mistakes happen. Let's see what happens. 5's cancel, right? So we're left off with 3 minus 1, which is 2. Generally speaking, we're giving equations that are known as Diaphantine, which means this: we'll be able to find integer solutions to these problems up here. Let me plot the points. I make mistakes sometimes. I want to encourage students that do make mistakes, please try to correct the mistakes before it overwhelms you when you get to the exams. So 0 minus 1, and then 5, 2. Again, I want to point out, I hate counting 2, by the way, but I got to count over 5. 1, 2, 3, 4, 5, and then go up 2. Right, so I have to count 5 and up 2, right? All right, let me point out what I just did. 1, 2, 3, 4, 5, and up 2. That's what that says over there. So what I'm going to do now, I'm going to draw my line through this. And again, I'm not looking for great artwork. All right, I want to go back to the other problem. I want to point out that, graphing lines, it looks pretty simple, but I also want to talk about other things they might ask you about these lines, right? So I'm going to talk about it. I'm going to talk about the X-intercept. How to get X-intercept? Set Y equal to 0 and solve for X. Well, you know what? I've already done that. It's this. Let's do the Y-intercept. We do set X equals 0. I already did that. It's 0, 0. Let me just went over here now. Let's talk about it. All right. Let's talk about the X-intercept. How do you get that? Set Y equal to 0. I can do that. Now, what I notice now is that I don't see it in my table. I don't see it. I don't see any Y in 0. I got to do it then. So someone says, where do you do it? Let's talk about that. Back to the integral equation. And I'm going to set Y to be 0. It's tough. I'm not saying it's going to be easy for you. Let's keep moving along. This would be 1 equals 3/5 of an X. Let's keep moving along. Multiply both sides by 5. And then divide through by 3. We'll keep moving. What do you get? 5/3 of an X. I'll write that down for you. Now, I realize what some people are saying. What's 5/3? Could I have read that from the graph? And my response to you is, no, you can't read that from the graph. However, once I know the point, my graph does look like that, right? Looking at it, what is 5/3? It's 1 2/3. And where's that point? The point's right over here. All right, that worked out beautifully, really did. All right, let's do the other point. And again, I know they didn't ask for it, but I write down Y-intercept now. How do you do that? Set X to be 0. I want to claim over here, that's already been done. I know what it is, -1. Is that in my picture? Of course it is. Let's go to the next one. And people get confused, myself included, by the way. I'm going to do the same exact thing I did before. It worked well in the past. It'll work well in the future. Now, by the way, someone says, well, what are you going to pick for X? No, I'm not going to pick for X. I'm going to pick for Y. I'm going to tell you the number one reason for this. I think it's going to be easier for me to do that. And what will be an easy value for Y? 0. I'm going to write this down for you now. X equals -3/2 times 0 minus 2. What would that give me? -2 for X. All right. I'm going to pick another value. And again, I want to emphasize over here, I think the easy one to pick is something for Y. And I'm going to pick a multiple of 2. So I'm going to pick the number 2 for Y. So what do you get? X equals -3/2 times 2 minus 2. Let's do the arithmetic. The 2's cancel, and you get -3 minus 2, which is -5. All right. I want to do another point for you, by the way. So this is why would you do that to me? Well, I'm thinking to myself is some of the teachers actually demand that you do more than 2 points. But here's the deal. If 2 points are good, you don't need more than 2 points. If these 2 points are bad, I'll know that by picking a third point because they won't be collinear. Now, what number would I pick now? Probably -2. Let me write that down for you. X equals -3/2 times -2 minus 2. And what would you get? X equals, that would be 3 minus 2, right? Which is 1. I'm going to plot these 3 points now, one at a time. All right, a little better now. So -2, 0. It's right there. Let's see, -5, 2. I'll verify these things for you. I did this one and did this one, and 1 minus 2, right? Now, what do I notice about those 3 points? And I could take many more points too. I notice those 3 points, they're collinear. I'm looking at it. So I'm pretty comfortable that I did a pretty good job. Do I make mistakes? Of course I do. That's your line. All right, let's write this down. X-intercept. How to get an X-intercept? Set y equal to 0. Let me put that down for you. And you know what? I see that in my table. It's -2. Oops, sorry about that. Let me get the y-intercept. I set x to be 0. All right, let me point out, and again, I'm not saying this is bad. I'm just saying I'm looking at this. And you might say, oh, I can read the y-intercept off this. I don't think so. And I'll tell you why. I'm really not sure what it is looking at my picture because my line is not that good, right? Like I would never want to testify that's the right guy, all right? If I do see 0, I'll put that down for you. But I'm really not sure about what the y is. All right, so let's go through this. So let's go back to the original problem. I'll circle it for you, this thing over here. And I'm going to do that. And what am I doing? I'm setting x to be 0. I'll put this down for you. I'm going to keep moving forward. I'm going to add 2 to both sides. And yeah, you might be faster than me at this, and that's fine. What would you get there? Multiply by 2, you get 4 minus 3y. And then I would divide through by -3. And you would get -4/3 is equal to y. Let me go back over here. And I think I got the number. -4/3. Now, to be honest with you, I'm looking at my picture now, and I kind of agree with that now. You know, what's -4/3? It's -1 1/3. It's right over here. Not bad. All right, let's keep going. And again, I know they're not asking for that. I want to point out you're going at some point, you're going to ask you for that. And here comes a more challenging problem for students. And what I've noticed a lot of students, what they do is they keep rewriting the problems over and over again. I'm not opposed to that. You can do that. What I really want to get across to you, though, is that these are really simple Diaphantine equations. What does that mean? I'm going to get really simple numbers for this. Now, I'm going to pick x to be 0 initially. And if I did that, what would I get? I'll write it down for you. You would get 2 times 0, that's x, minus y is equal to 5. And 2 times 0 is 0, so you get minus y equals 5. I'm sorry. Let me get my eraser out. I jumped the gun there. So I would know y is minus 5. And here's a really nice principle of Diaphantine. If you can find one integer solution, an infinite number are there for you to do. An infinite number. Let me pick another one. I'm going to pick x to be 1. If it's not easy, I'll erase it and try again. All right, so I'm picking x to be 1. So what'd you get? 2 minus y is equal to 5. Again, if x is 1, 2 times 1 is 2. You get minus y is equal to 3. I subtract 2. So y is minus 3. And I think you probably know I want to pick another number because, I had 2 points is enough. I'm kind of testing myself out. Let's try 2. Plug it in. What do you get? 4 minus y is equal to 5. All right. It's work. I know that. So what do you get? Minus y. Take 4 from both sides is 1. So y is minus 1. I'm going to plot these points one at a time. And let's see, 0 minus 5, right? I got to count down 5. I want to point out what I did. I'm doing this point over here. That means nothing along the x-axis, but I have to move down 5. 1, 2, 3, 4, 5. I did that point. Let's do this point over here, which is 1 down 3. I'll put that over here for you. All right, let's do the next point, which is 2 minus 1. Before I do that, I want to point out to you 1 down 3. Now I'm going to 2 down 1. What do I notice about those 3 points? They're collinear. Again, I'm not claiming my lines are perfectly drawn. They don't have to be. Let me talk about the X-intercept and the Y-intercept. Well, X-intercept, what you do is set y equal to 0. For Y-intercept, you set x to be 0. Well, I know what that looks like. It looks like a point. And this looks like a point. Now, I have one of the points down the table right. I have this one over here. So that's 0 minus 5. I got this covered. That's the Y-intercept. But I don't have the other one where it says y is 0. So go back up here. I'm going to circle what I'm doing. And what would this give me? Well, let me put it over here. I'll write it down for you. And I'm setting the y to be 0, right? So what do you get? 2x minus 0, which I'm not going to put that down, is 5. So what does this lead to? X is 5 halves. I'll write that down for you. All right. So I want to claim that this point is done for me. So someone says, oh, I could have read that from the graph. No. And the reason that my line is very poorly drawn. It's a hack job is what it is. What is the X-intercept? I'm looking at it and my line is really poorly drawn. What's 5 half? It's 2.5. It's actually over here somewhere. Someone says, oh, your line, if you just, maybe drew a little better line, but I want to claim you need a ruler to do that. Look how wavy my line looks. All right. It really does look wavy. It doesn't look like a really good looking line over here. I missed it. So let me point this out. You're not going to be able to read this from most people's graphs. It's not going to happen. All right. Be aware of that. On exams, though, we're not looking for great looking lines. Put a couple points down, draw a line through it, and you did a great job. All right. Let's go to the next question. That was what number was that? Oh, number 4. I guess I go to number 5 now, right? There you go. Let's put 5 down. And again, please, these are going to be easy. If you rewrite this guy, though, that's on you. I'm not asking you to rewrite these guys. What I'm asking you to do is come up with points. If rewriting helps you, rewrite it. If it doesn't help you, don't rewrite it. I'm going to claim this one's going to be really easy to do. I want to tell you what I'm looking at, this over here. And I see 5x plus 2y is 7. I'm looking at that, and I'm pretty much guaranteed at this level of the game that this is going to be easy. What do I mean? The solutions to this are going to be on your fingers. So I'm going to try 1. Someone says, why don't you try 0? 0 does not look productive. If x is 1, what do I get? I get 5 plus 2y is equal to 7. Well, I got to be honest with you, that looks really simple. Because take 5 from both sides, you get 2y is 2. So y would have to be 1. Here's the deal. If you can find one easy answer, an infinite number of answers are there for you to look at. They really are. I realize for someone saying, I don't think I could do another one. What I want to claim is I'm just going to hunt and peck for it. If it doesn't work, I'll erase it. So what do you think a good number after 1 would be? I would try 2. All right, let me just get my eraser out and erase this business over here. I'm gonna try 2. Maybe it'll work. What do you get? 10 plus 2y is equal to 7. Then I get 2y is equal to minus 3, and y would equal minus 3 over 2. I got to be honest, I don't like that because it's not integer. So I'm going to erase it now. So someone says it's going to take me forever. Not really. There can be Diaphantine simple ones at that. So let's say 1 worked really nicely. 2 is a disaster. This next number I try 3. I don't know, maybe it doesn't work. But these are finger numbers. What do you get? 15 plus 2y is equal to 7. 2y, I'll take 15 from both sides. You get minus 8. Well, there you go. Bingo. Really simple. Minus 4. What do you mean by that? Integer numbers. All right, I'm going to do something that sounds crazy to a lot of students. I'm going to erase this up here. But I'm starting to realize that lines are very simple pattern problems. And I want to go through the pattern with you. This is what's known as a delta x. This is what's known as a delta y. Let me do one thing at a time. If you're at 1 and you get to 3, how much did you go up? 2. So I think I probably could do this all day long. 1 to 3 is up 2, 3, 2, you go by 2, right? 5, and 7, and 9, and then 11, and then 13. Let me go backwards. I go down by 2. What do you think would go there? Minus 1. That's not bad. I don't know if it's right, by the way. I'm saying I think there's a pattern to it. Let me do the delta y, and this is tough. I'm not saying it's going to be easy for you. If you're at 1 and you get to minus 4, I hope you realize you had to go down by 5 units. Let me see if I can do that. If you're at minus 4 and you go down 5, you'd be at minus 9. Then where would you go? Minus 14, minus 19, minus 24, minus 29. If you go in the other direction now, I want to point out what you're doing over here is you're not going down by 5, you're going up by 5. What number would go there? 6. A lot of students often ask me, do I need to understand what you did? We would like you to try, but if you can't, that's fine. All right. I'm going to say these are the ones we did by trial and error. The other ones we did by patterns. I'm not saying they're right. I want to see if they're right, though. Someone says, how do you know they're right? I check them. So let's just check the first one. I want to check this one over here. What would you get? If x is minus 1, you get minus 5. And if y is 6, you get plus 12. Does that give me 7? Yes. Let's check this one. I don't know. Maybe it doesn't work. If x is 5, you get 25. And if y is minus 9, you get minus 18. Does that give you 7? Yes. Let's do the next one. I know it's tough. If x is 7, you get 35. And if y is, minus 14, you get minus 28. Does that equal 7? Yes. Let's try this one. I know it's tough. 5 times 9 is 45. And 2 times minus 19 is minus 38. Does that give you 7? Yes. Let's try this one. What do you get? 55. And what's 2 times minus 24? Minus 48. Does that give you 7? Yes. Let's try this one. And by the way, no, I don't want you to keep doing this. This is an infinite loop. We want you out of that infinite loop. What do you have there? What's 5 times 13? What's going to be 50? And that's 65. Again, 13 times 5 is 50 plus 15 is 65. And what's 2 times minus 29? What's going to be minus 58? Does that equal 7? Of course it does. Here comes my problem. Which point are you going to plot? 1, 1, super easy. Let me blow it up a little bit. What's the other one super easy? I think in -1/6 is easy, right? Hope you understand what I just did there. I think 3 minus 4 is pretty easy too. I think you're seeing a pattern though. I think 5 minus 9 is easy too. It's a lot of counting. I hate counting too. Oh, I don't want to do the other ones. Let me see if I did the counting right though. 1, 1, 1 over 1 up. I did that right. 3 minus 4. 1, 2, 3. 1, 2, 3, 4. Yeah, I got that one. Let's see if we did 5 minus 9 right. Who knows? Maybe I did it wrong. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. I missed it. It's over here, isn't it? Get my eraser out. And erase that little dot there. All right. Someone says, did you need to graph it? Not really. Well, what I know about those things? They're all collinear. I'm going to draw my line in now. And let me repeat this. My lines are never good. All right. They're never good. I do the best I can. And let's see, -1/6. Did I do that right? 1, 2, 3. I'll count. 1, 1, 2, 3, 4, 5, 6. Yeah, I did it right. All right, let's talk about the other stuff they want you to get from this. All right. And I know it's tough. And I really do know that. And I want to go back over here. And I want to do the X and Y intercepts. I'm going to push this over here. Hey, you set Y equal to 0. What do you get? 5x. We'll look at our graph later, by the way. And x would equal 7/5. So my X-intercept is going to be, X is going to be 7/5. And the Y is going to be 0. I want to point out 7/5 is going to be 1 and 2/5. All right, let's do the Y-intercept. That's 0, by the way. Set X equals 0. How do you do that? Well, you just like X 0. You get 2y is equal to 7. What's y? 7/2. Let's write this down. X is 0. Y is 7/2. What's 7/2? Well, 2 goes in 7 3 times and half. All right. Now, again, I want to emphasize here, you're not going to get these from the pictures. All right. Now, sometimes I think I can get it from the picture. Now, I want to point out the X-intercept 1 and 2/5. There's no way I could read that. Like I would say that's 1.5. But I'll be honest with you, it's not bad. I mean, 1 and 2/5, it's almost 1.5. Now, what's the other one? What's 7/2? It's 3.5, right? Let's look at this one over here. I'll blow it up. Again, there's no way I can read that from that. But you know what? Thinking about it, that does look like 3.5 now that they say it. All right. So here's the deal. Generally speaking, pick easy numbers. And then if you have ask for X, Y-intercept, then do it. All right, let's do this one over here. Again, don't be confused. Be encouraged if we give you a Diaphantine, which means it's going to be really simple. When I mean Diaphantine, they're going to be low integer Diaphantine. Put my table down. And let's take a look at it. Well, I'm going to set X to be 0. It looks pretty easy. And if you did that, what would you get? It could be easier, 0. Set X to be 1. What would you get for Y? 1. I could do this all day long. X and Y are the same numbers. Not that I want to do it, but you can do it all day long. All right. What's the delta X in this direction? Is 1. What's delta Y in this direction? It's 1. Let's graph it. All right. What point do I want to put down? 0, 0. 1, 1. 2, 2. 3, 3. 4, 4. 5, 5. Someone says, do I need to put all those points down? Absolutely not. All right. What I'm going to do? Draw a line through it. This is the kind of graph that I think I could read it. I think I could read this graph over here. What's this point over here? 0, 0. This is both an X and a Y-intercept. All right, that one's done. Let's go to the next one. Will be number 7. And again, I can't say enough times, it's going to be a line. That's what we're doing in this section over here. They're not going to give you things that are not lines. And let's put our table down. This tends to confuse a lot of students. We're not trying to confuse anyone. So I'm going to pick X. I'm going to pick X to be, I don't know, let's pick 0. Let's see if it works. Oh, gee, Y is 2 then, right? Let's pick another value for X. I'll pick 1. You get the idea? What's Y? It's 2. It says right here, it says Y is 2. Let's do another one. Let's take X to be 2. What's Y? It's 2. Let's pick another one. 3. What's Y? It's still 2. I hope you realize that Y is always going to be 2. It's the X can be anything it wants. All right, let's plot it out, see what we look at. And again, it's important you start thinking about what you've been given. So I'm going to do 0, 2. 1, 2. 2, 2. 3, 2. You get the idea. What's this line over here? Yeah, I'm not doing a great job. It's a horizontal line. All right, let's talk about it. X-intercept. Look at the picture. Is there an X-intercept? No, none. Why is that? You can't find a point in there where Y would be 0. Y is always 2. How about the Y-intercept? Where X is 0. What's in my table? It's 0, 2. That was simple. It's right over here. All right, let's go to the next question. Go to number 8. Number 8 looks like a very similar question. And kind of, put a table down. X and Y. I'll pick X to be, well, I can't pick it to be anything except for this. X has to be -1. What's Y? Anything you want. 0. X is always -1. Y can be anything you want, though. Doesn't depend on Y. Let's see if we can plot the points. All right, one at a time. Let's see, -1, 0. -1, 1. -1, 2. -1, 3. Line it. And again, I know my lines are not great. I realize that. All right, what kind of line is that? It's a vertical line. Let's write this down. X-intercept. I'm looking at my picture. It's when the Y is 0. It's -1, 0. How about the Y-intercept? Look at the picture. It never hits the Y-axis. All right, why would the X would never be 0? The X is always -1, so there's none. All right, let's keep going. That's number 8. Let's go to number 9. And again, I want to encourage you that these are going to be really simple Diaphantine equations. All right, I'm still using my table, but I want to be honest with you. I'm not reading their sentence, by the way. I'll read in a second. So I'm going to set X to be 0. Y would be 4. Again, I'm looking at this equation over here. That makes sense to me because 2 times 0 is 0 plus 4, that would be 4. I'm going to set Y to be 0. And what would X be? Whoops, sorry about that. I'm going to set Y to be 0. What would X be? Well, 2. Why is that? 2 times 2 is 4. If Y is 0, it would be 4 equals 4. So I'm going to say these are really simple points to plot. So 0, 4. All right, I'm looking at this thing over here, 2, 0, right? I suppose could you get other points? Of course you could. I'm going to go through that with you. And I'm going to do it by counting. Right? We're going to do this. Now, some students say they can't do this, that's fine. If you can't do that, just tune it out. If you're at 0 and go to 2, you went up 2 units. If you're at 4 and got to 0, this is the delta Y, by the way, that's -4. Right? I'm going to put another point down. If you're going up by 2, what would you get? 4. If you're going down by 4, what would you get? -4. I want to see if that's true, though. If X is 4, what do you get? 8. If Y is -4, -4, does that equal 4? Of course it does. You could keep doing this game all day long. Not that we want you to do it, by the way, but I'll put that point down for you. 4 - 4. All right, what do I know is collinear? Put my line through it. I will go back and read it, but before I do that, I just want to say I didn't read it. I'm going to put the X-intercept and Y-intercept down. I'll write this over here, X-intercept. What's that X-intercept? It's when Y is 0, right? So it's 2, 0. What's the Y-intercept? Look at my table, by the way. You might say it's by chance. That's 0, 4. What'd they say? Find the X and Y-intercepts. I've done that by chance and graph it. And I graphed it. I'm done. Okay, let's go to 10. Let's see if there's a 10. 10. Oh, I don't want to do this. By the way, the reason I want to do it is that at Essex County College, they do not expect this from students. There's no expectation of it. What I'm claiming, though, is that no matter what the expectation is, you got to start to realize there's a bigger world out there. And that bigger world has bigger expectations than I might have or that Essex County College might have. The more you can do, the better it is for you. So what I would recommend here, I think you can do this problem by reading. And reading is going to be your gateway to your educations anyway. So I think you could read this. But this is not going to occur in WebAssign, and it's not going to be an exam. All right? You could read this. For example, it says, replace the comparison symbol with an equality. I think you could do that. I think you could read the next thing. I think you could do it. I think eventually, if you did that, you would get the picture providing to you. Then you could do number 11. This will bode well because at other places, they might have different expectations, higher expectations. You might be surprised by that. If you have access to a textbook, you might be surprised how big the textbook is, how much more information is, and what small subset we actually address in the textbook, a very small subset. So here's my encouragement to you. Look at books. See what expectation is in most books. They can be quite large. In fact, so large, in fact, that you can't get through a book. It does happen. All right, so we're done with that section. What do you need to do? Move forward. All right, try problems on your own. Thank you for paying attention.